be is if I wanted to take the limit of this function here, what I might try is plugging in the -5. Now if I plug in the -5 in the top, I'll get a number, but the problem is I'll have 0 in the denominator and I can't do that. Okay? So there's lots of ways that we can address that, but I just want to focus on the concept of limits first. So what I'd like to do is let's graph this, because it's all about the graphs and all about the table of values when it comes to approximating the rate of change. So up to this point, we've discussed that functions change, their values change, and that change is dependent upon the function itself. Okay? So if I graph this function in my calculator, I'm going to say x to the 4th plus x squared minus 1, close my parentheses, divided by x plus 5. And so what I was talking about is when I look at this thing, if I see this vertical line? That's an asymptote. That isn't the graph. That's a vertical asymptote that's saying that x cannot equal -5. If I hit trace and I plug in the value -5 and I hit enter, no y value. Okay? So now how do I figure out what this limit approaches? Well, what I can do is I could look at the graph. If I were to zoom out a little more, this is a very interesting graph. It's a really complicated graph, but if I zoom out a little more, you'll see that that vertical asymptote is going to have an interesting behavior. So if I come over here at, say, -4.99 and I plug in that value, look, I get a really big y value. So as I come closer and closer to -5, what's my y value doing? Blowing up. It's going towards infinity quickly. Okay? Now what happens if I go a little bit beyond that? So if I hit -5.01, well, it's doing the opposite thing. It's going down, right? Quickly. And so if I were to kind of sketch a graph, what I'm looking at is when x equals -5, I have a vertical asymptote, and the behavior of the graph looks like this. And we can't see it on my graphing calculator, but somewhere down here, my graph is approaching -infinity. So this is the graph on the xy plane. And this line right here is x is equal to -5. And because of the function, x can equal -5. So in this particular scenario, I cannot take a limit. I can't do it. It's not possible. So in this scenario, by looking at the graph, I just can't do it. So why would I say that? So if I can't take the limit, guess what I can't do with this function when x equals -5? A whole bunch of calculus. Right? Because we said that the formal definition of a derivative occurs when h approaches 0, and that we pick a value, but if I pick this value -5, and I can't take a limit of it, I'm kind of in a bad spot.
Wait, why can't you take a limit of it? Because it can.
Well, when we say the limit, what we're looking at is what is it approaching. So if we come at this from the right-hand side, what is it approaching? Positive infinity. When we come at it from the left-hand side, what is it approaching? It's not approaching the same value. Let me show you another one. You guys want to see another one? Watch this. If I take the limit as x approaches -2, and I have x plus 2 on the bottom of the denominator, okay, and then I have x squared minus 4. Let me move my graph over here. Can I plug in x equals -2 in this equation? No, it's just like the other scenario. But now watch, the graph will look a little different. So we need to know the graphs, kind of, yeah. And then we're going to need to know a little bit of algebra, because I want to show you. I'm really jumping ahead because I think it'll help you to understand what it is that we're trying to do when we talk about the limit. I want you to understand the concept before we dive into the algebra part. So I have x plus 2 on the bottom. Oh, did I? We'll insert right there. All right. So now when I look at this, oh, wait a minute. That looks like a regular graph. That looks like a regular line, which is weird because it's x squared over an x, right? But when you think about it, what's x divided by, or what's x squared divided by x? X, right? So it should be linear. But now if I hit trace, watch what happens when I go -2. Uh-oh, SpaghettiOs. So now if I look at this, I've got an xy plane, and if I were to write the graph down, really what's going on here, when x equals -2, right, this is x cannot equal -2. If I were to graph this thing, here's what it looks like. It doesn't look like this on your calculator, but it kind of looks like that. All right. So now, what does it look like? Does it approaching the same point, though, from both sides, left and right? Yeah. We haven't talked about it yet, but then that has a limit. I haven't gone through the formal definitions and how we can prove this. But watch what happens. If I plug in -1.999, what does it look like it's approaching? 4. -4, right? Now if I plug in -2.01, what does it look like it's approaching? Yeah, so if I could get really, really close, what does it look like the answer should be? It should be -4, right? Is that what it would be algebraically? No. But wait a second. Let me show you something. If I take the limit of this, what is x squared minus 4? Isn't that x plus 2 times x minus 2? Because that's the difference of squares, right? Isn't that the same thing? Well, what happens when my x plus 2's? They cancel out. And what happens when I plug in -2 there? I get -4. Now what I want you guys to realize is that x minus 2 is a completely different equation than x squared minus 4 over x plus 2. And what I mean by that is if I come in here and I graph, it's the same line right on top of it, but without the domain restriction. So if I say x plus 2 on the top, and I graph this, oh yeah, minus, thank you. It looks like the same line. Now watch this, when I hit trace, if I go to -2 and hit enter, see how it's undefined? But see the graph that I'm looking at? I'm looking at the first one, which is x squared minus 4 all over x plus 2. But now if I hit this button down and hit -2, guess what? It's defined. So what I'm really doing, and this is what we're going to learn how to do, is that the orange line is x squared minus 4 all over x plus 2. But I'm just drawing another line right over the top of it in purple that is really just x minus 2, where one of them is defined and the other one isn't. So with limits, what we're going to look at, all that stuff we talked about yesterday about epsilon and delta and all that stuff, it helps if it's defined. Okay? That's it for now.